We've seen how we can gain or lose electrons. We cannot gain or lose protons because that will change the identity of our element, but we can gain or lose electrons to give us ions. And if we gain an electron, we are gaining a negative charge, so our atom becomes more negatively charged, or it becomes known as an anion. If we lose an electron, we lose a negative charge, so our atom becomes more positive, and it becomes a positively charged cation. And we've seen we can determine such charge by determining our number of protons minus our number of electrons. So let's do an example. We have a magnesium ion with 10 electrons. Of course, we have the number of protons because we can look up magnesium in the periodic table, and we find that it has an atomic number of 12, which is the number of protons. Now we just plug it into our equation up here. So our number of protons is 12 minus 10, which is our number of electrons, which gives us a positive 2. So we write magnesium ion, cation, like so, with the charge as superscript. A sulfur ion with 18 electrons. Sulfur has a chemical symbol S. It has an atomic number of 16, and so it has 16 protons. Now we plug that in, and we find that 16 protons minus the number of electrons that we're given, which is 18. This gives us a negative 2. So sulfur is written like so. And in this case, it is an anion because it's negatively charged. This is a cation because it's positively charged. Now, in any neutral molecule, you will always have the same number of protons as your electrons. So you will see that in this equation, if I had, for magnesium, if I had 12 protons and 12 electrons, then my charge will be 0. It'll be neutral. Now you go ahead and do an example and replay this video to see if you got the correct answer. If we have a nickel ion with 26 electrons, we know that nickel has an atomic number of 28. So our number of protons, 28, minus our number of electrons, 26, will be positive 2. So nickel is a cation. Let's do bromine. With 36 electrons. Bromine has an atomic number of 35, and so we plug in our number of protons minus our number of electrons, which gives us negative 1. So we write bromine as negative, like that. We don't have to write bromine as negative 1 like that, because whenever we write the negative by itself, let's assume the 1 is there. Now let us see how we determine the number of protons and electrons when we are given the anion. So here we are given calcium plus 2. We can use our formula, or we can think about it logically. We can say, well, we know that calcium has an atomic number of 20, so it has 20 protons. That should be very easy for you to always answer. Just if you're given the name of the element, you should automatically know the number of protons. Now, if it was neutral, we'd have 20 electrons, right? But this is not neutral. It has a positive 2 charge. What the positive 2 charge is saying is that we lost 2 electrons, right? because when we lose electron, we lose negative charge and we become more positive. So in this case then, it's 20 minus 2 electrons. So we have 18 electrons and 20 protons. Now go ahead and try one yourself, and let's find the number of protons and electrons in an oxygen anion this time. So we have oxygen anion, and the Z number for oxygen, or the atomic number, is 8. So we have 8 protons. If it was neutral, we'll also have 8 electrons. But guess what? It's not neutral. We have a negative 2 charge. And since negative 2 charge is telling us that our atom gained 2 electrons. It gained 2 negative units. So now we're adding 2 electrons. And so this gives us 10 electrons and 8 protons. We can also predict the charge on our ions based on the position on the periodic table for some elements, usually the main group elements. And we do that because the number associated with the letter A above tells us how many valence electrons we have, or how many outermost electrons that we have for that element. So we predict the charge acquired by the element based on its position on the periodic table relative to the nearest noble gas. Because noble gases are very inert, they're unreactive, because they're very content. They have 8 valence electrons in their outermost shell. So everything else wants to also have 8 valence electrons in its outermost shell. So it will gain or lose electrons to achieve that. So let's do an example. Let's talk about the fluorine atom, or any halogen. It has 7A, so it has 7 valence electrons. So let's draw an atom of fluorine and say, so this is its nucleus, and then we have the electrons orbiting around like planets would around a sun. And we have 8 electrons in each orbital. Now, in the outermost orbital, because we have the number 7 here, it means there's 1, 2, 3, 4, 5, 6, 7. There's 7 electrons, but we want 8 because we want to achieve the highest, we want to achieve fulfillment. We want to have 8 in our valence electrons. So it looks like we just need one more to make us happy. So since we gain one more electron, then our fluorine atom becomes -1 charge, and so do all of our halogens. And that is why the halogens are so reactive, because they're just dying for one more electron. On the other hand, if we look at group 1A, in group 1A we'll draw our nucleus, which is our sun, and we'll draw our electrons orbiting that, and in our outermost orbit, because we have the number 1 here, there's only one lonely little electron. Now, to get to 8 valence electrons to its nearest noble gas, which is neon, it will have to gain 7 electrons, which is really a lot. It's not possible. So which is easier for it to do? Gain 7 electrons, or just lose its outermost electron right here? And so here then we're left with an octet, 8 electrons going around in the valence shell, the outermost shell. So since we lost an electron, we became more positive, and lithium becomes +1. So let's do more examples. Based on the position on the periodic table, what ions do barium and iodine tend to form? Well, we know that barium is in group 2A, so it needs to get to group 8A. It needs to either gain 6 electrons, which is not or lose 2 electrons because of its outermost shell. Now, of course, it's much easier to lose 2 electrons than gain 6, so it will have a positive 2 charge. Iodine is in group 7A, and it needs to get to 8A. So it can gain 1 more electron or lose 7 electrons to get to the nearest noble gas. And of course, it's much easier to gain 1 electron, so we will have iodine as -1 charge. Okay, it's your turn. Go ahead and give this a try. We have potassium, and potassium is in group 1A, and it needs to get to 8A, to its nearest noble gas. So it can either gain 7 electrons or lose 1 electron. Of course, it's much easier to lose 1 electron, so since we lost 1 electron, we end up becoming more positive, and 1 electron, so it's K+. For selenium, Se, we are in group 6A. We need to get to 8 valence electrons. Now, is it easier to gain 2 more electrons or lose 6 electrons? Of course, it'd be much easier to gain 2 electrons. So since we gained 2 electrons, we gained 2 negative charges and became more negative. So it's going to be -2.